Hello viewers, welcome to the video series of the topic Fourier series. Fourier series that is for any function f of x. This series a0 by 2 a1 cos 1x plus a2 cos 2x plus etc. plus b1 sin 1x plus b2 sin 2x plus infinite terms. This series is called the Fourier series expansion of the function f of x. But this function f of x has to be a periodic function. Then what is periodic function? Periodic function for the function f of x that repeats itself in the interval at equal intervals. If the function f of x repeats itself at equal interval, then f of x is called periodic function. Example, if f of x is equal to sin x, if we take sine function, then sine function is a periodic function. This is an example of periodic function. Sin x is an example of periodic function. So let me take the waveform of sin x: 0, pi, 2 pi, 3 pi, 4 pi, etc. So sine wave will be takes 0 to 2 pi to complete one wave and repeats, again it repeats, it goes on. So this is the sine function, sine wave. So it repeats after 2 pi and in the interval 0 to 2 pi. After that it repeats itself. So the function, so periodic function is that repeats itself in that equal interval 0 to 2 pi, 2 pi to 4 pi. So it is equal interval. The length of the interval is 2 pi length of the interval. So sine function repeats itself in the equal interval. So sine function is a periodic function. So we can write, so if it is a sine function, then we can write f of x is equal to f of x plus t, f of x plus 2t, everything will be equal. That is, f of x is a sine, if it is a periodic function, then f of x plus t, etc., f of x plus nt, where t is the period of this function. 2 pi is the period of sin x. So f of x is sin x. Sin x is equal to sin x plus the period of the function is 2 pi plus etc. f of sin equals sin x plus n pi. Everything will be equal to the function itself. Sin x is equal to sin x plus n pi. So sin x is a periodic function. It repeats itself in a regular interval after regular intervals. So we can expand a series like this for that function, periodic function, as a0 by 2 a1 cos 1x plus a2 cos 2x plus b1 sin 1x plus b2 sin 2x. So for such function, we can expand the series a0 by 2 plus a1 cos 1x plus etc. plus b1 sin 1x plus etc. So series of adding cos series and sin series plus a0 by 2, we get the function. So that is f of x is equal to a0 by 2. We can write this as the summation of an cos nx, where n is 1 to infinity. It is an infinite series. So I will write this as like this in short form. And this sine series will be summation n is equal to 1 to infinity bn sin nx. So this is the Fourier series of any function. So that should be a periodic function. Then what are the Dirichlet conditions? The conditions are the f of x value is a finite and it is a single valued. What we get is a finite, and this a naught, a n, b n are all constant. It can be determined and substituted so that the value of f of x is a finite and it is a single valued. That's what Dirichlet condition says. And the f of x, if f of x is a discontinuous function, then its point of discontinuity will be finite in number, and f of x has maxima and minima finite in number. These three are the conditions of Dirichlet. Now let us go. The value of a naught, a n and b n can be evaluated. That's what the Euler's formula says. Euler's formula says that if the Fourier series of f of x in this interval is important. This interval is given by this one, a naught by 2 plus the cos series plus sine series, the sum of cos series plus sine series plus a naught by 2, where this a naught, a n, b n can be evaluated. The values can be evaluated by solving these integrals, that is within the alpha to alpha plus 2 pi interval. So integrate within the limits alpha plus 2 pi, solve the f of x integral, then you will get a naught. Solve the integral from alpha to alpha plus 2 pi within this interval, f of x cos n x, you will get by pi, you will get a n. Solve the integral f of x sin x within alpha to alpha plus 2 pi, divide by pi, you will get the constant bn, that is the constants a naught, an, and bn. So you will get these a naught, an and bn by solving these integrals. This is called the Euler's formula for the Fourier series function f of x. There are three corollaries for this Euler's formula. There are three corollaries for the Euler's formula when we have the intervals taking different values. That is, if the interval is alpha, in this interval, if I take alpha value as 0, and if I take another corollary is if alpha value takes minus pi. So if alpha value is 0, then the interval is 0. If alpha is equal to 0, alpha plus 2 pi, 0 plus 2 pi is 2 pi in this interval, and another one is in the interval 0 to 2 pi, and if alpha takes minus pi, then the interval will be minus pi less than x less than minus pi plus 2 pi, that is pi in this interval. So 0 to 2 pi interval and minus 2 pi to pi interval. So first corollary is when alpha is 0. First corollary is alpha is 0. So the interval is 0 to 2 pi, 0 to 2 pi interval. So the functions, as usual, the function expansion is the sum of cos and sine plus a naught by 2. And a naught is, what it says is 1 by pi. The integral should be evaluated between the intervals. So this will be 0 to 2 pi f of x dx. You will get a naught. 0 to 2 pi f of x cos n x by 1 by pi. You will get a n. Integral f of x sin n x within 0 to 2 pi. Within this interval, you will get bn. So the next case is when alpha value is pi, minus pi. So the interval is minus pi to plus pi. So the Fourier expansion is f of x is a naught by 2 plus this cos series plus sine series, and a naught is 1 by pi minus pi to pi f of x dx minus pi to plus pi f of x cos n x, 1 over pi is a n, the value is a n, minus pi to plus pi f of x sin n x. If you solve this integral, you will get bn. That is what the corollary 1 and corollary 2 says. And the third corollary says that if it's a discontinuous function, if f of x is a discontinuous function and its point of discontinuity is x naught, then what happens to the series? How to evaluate these values a naught, a n, b n is, if we know the point of discontinuity of this function, then within this interval, that is alpha x naught, in this interval, if this is the point of discontinuity and it lies within this interval, then we can split this interval to from alpha to x naught and x naught to alpha plus 2 pi. From alpha to x naught to the point of discontinuity where the function is discontinuous, alpha to x naught plus x naught to alpha plus 2 pi, x naught to alpha plus 2 pi. So if you evaluate f of x within these limits, then you will get a naught, of course 1 by pi, you will get a naught, and 1 by 1 over pi alpha to x naught. Similarly, alpha to x naught f of x cos n x plus x naught to alpha plus 2 pi f of x cos n x, you will get the value of a n. And similarly, alpha to x naught f of x sin n x dx plus alpha x naught to the point of discontinuity x naught to alpha plus 2 pi, what you get is 1 over pi, what you get is bn. So if it happens to be a discontinuous function and we know the point of discontinuity where the function is discontinuous, then we can still we can solve the get the values, and it is like this. So alpha to x naught and x naught to alpha plus 2 pi, if you integrate you will get the values.